Alright, this is practice problem 3.16. So isopropyl alcohol, sold as rubbing alcohol, is composed of carbon, hydrogen, and oxygen. Combustion of 0.255 grams of isopropyl alcohol produces 0.561 grams of carbon dioxide and 0.306 grams of water. Determine the empirical formula of isopropyl alcohol. Alright, so for this, if we just think about that we're producing carbon dioxide and water, and we're trying to find how many carbon, hydrogen, and oxygens were in the original isopropyl alcohol. Okay, we know the number of atoms can't change, and so we just need to figure out how many grams are actually added initially and convert that backwards. And so really the strategy here is that we need to take the grams of CO2, which we're given. We can convert those to moles of CO2, which then allows us to convert that to moles of carbon in that sample, which then can tell us the grams of carbon in that sample. Okay, we're also going to do this for water as well. Okay, so we have the grams of H2O, which then we can convert to the moles of H2O, which then can go to the moles of just hydrogen in that sample, hydrogen atoms, and then that can take us to the grams of hydrogen. Okay, so it's really just thinking this out. And so what we're starting with is we have 0.561 grams CO2, okay, and so we know that there are 44.0 grams of CO2 in 1 mole of CO2, and in 1 mole of CO2, how many moles of carbon atoms are there? Well, there's just one, right? So we have 1 mole of carbon atoms. And for 1 mole of carbon, right, we would have 12.0 grams. And so our moles of carbon are going to cancel, our moles of carbon dioxide cancel, grams of carbon dioxide cancel, and we are left with 0.153 grams of carbon. Okay, we can then do the same thing for the water. Okay, although here we have to remember that what we're going to notice is that there are 2 moles of hydrogen for every 1 mole of water. Okay, and so here we're starting with 0.360 grams of H2O, and there are 18.0 grams of H2O in 1 mole of H2O. And in 1 mole of H2O, and this is really where you always have to pay attention, you have 2 moles of hydrogen. Okay, and then for every mole of hydrogen atom, there is 1.0 grams of hydrogen. Okay, so our moles are going to cancel, moles of water are going to cancel, grams of water are going to cancel, and what we're left with is 0.0343 grams of hydrogen. Alright, so at that point we have grams of carbon, grams of hydrogen. We then need to calculate the grams of oxygen. Okay, and so if we come back up here, we know that our original sample had 0.255 grams, so 0.255 grams. We're subtracting the amount of carbon that we have, right? 0.153 grams of carbon. And we can subtract the grams of hydrogen, so 0.0343 grams of hydrogen. So that leaves us our grams of oxygen, because the only products that we produce are both carbon dioxide and water, which is just carbon, hydrogen, and oxygen. So the total of those must add up to our total sample size. And what we find is that we have 0.068 grams of oxygen. So the last step is converting these to moles and then dividing by the smallest whole number like we did before in order to find the empirical formula. Okay, and so I'm actually going to take this on to the next slide. Alright, so at this point we can then convert to moles of carbon, moles of hydrogen, and moles of oxygen. And we know how many grams we're starting with, so we have 0.153 grams of carbon, 0.0343 grams of hydrogen, and we have 0.068 grams of oxygen. Okay, and then we're just going to multiply these into moles. So in 1 mole of carbon, we have 12.0 grams of carbon. In 1 mole of hydrogen, we have 1.01 grams hydrogen. And for oxygen, in 1 mole of oxygen, we have 16.0 grams of oxygen. So what we find is that we have 0.128 moles of carbon, we have 0.0340 moles of hydrogen, and 0.0043 moles of oxygen. And now we're looking for the empirical formula, so we can just divide by the smallest whole number, which is going to be the oxygen. And so each of these then we can divide by 0.0043, 0.0043, and 0.0043, and then we can solve for each one of these. So this one we get 1. For hydrogen we basically get 8, and for carbon we get 3, and so our final answer is C3H8